Alright class, in this lesson we're going to take a look at an application of synthetic division where instead of actually dividing, what we're being asked to do is find out what the answer to this function would be if we were plugging in -2. Notice it says find f of k, which means take your -2 and plug it in for x. In other words, put -2 here, here, and here. Well, you might be thinking, well, that doesn't take synthetic division. I already know how to do that. That's because you do. But what I'm trying to teach you is another way to do it, because it helps us when we're plugging in a number like 2 plus I. So stay tuned and make sure you're following along with this, because it is actually an applicable thing where I know you could actually take your calculator right now, plug in -2, and find the answer. Okay, the answer is going to be -29. If you plug it in a calculator, that's what you get. So let's work it out using synthetic division and see how this goes. So what you do is you take your synthetic division coefficients, the 2, -5, -3, and 11, and we want to work synthetic division with it. But the number we're going to put over here in the box is not changing the sign here. We actually leave the sign the same. It's going to be -2. The reason for that is because this time we're giving k equals -2 instead of having like k plus 2 like we were on the previous lesson. It's kind of like this k plus 2 is now equal to 0, and we got the k alone by changing the sign and getting k equals -2. It's kind of what we were doing in the last lesson, was changing the sign, which meant moving it to the other side and actually getting a solution or a root. Okay, so that's what these numbers are on the outside. They're actually roots. Okay, and that's why we have been changing the sign. Anyway, so I take this -2 and leave the sign the same on these types of problems, and I do synthetic division. So I draw my math bar, bring my 2 down. Okay, and what I do then is take my 2, times it by my -2, and then bring it over here, and that should give me -4. And then I take my -4 and -5, add them, get -9. Take that, times it by -2, bring it over here. I should get my positive 18. Okay, let me get rid of some of the lines there. Positive 18, and then I go ahead and combine that, and that gives me 15. Take that, times it by -2, and then bring it over here, and that's going to give me -30. When I add that, that gives me my -29. Now, notice the -29 is the answer I said it was going to be earlier. That's because whatever your remainder is in this process is actually your solution. What that means is that f of -2, if I was to plug in -2, the result would be the -29. This is called the remainder theorem. Whatever the remainder is actually the answer, the result of if I had plugged in -2 for all the x's up here. Okay? And why that's nice is because if we have a harder problem, like this one, with like an imaginary or complex number, it actually goes a little bit quicker than actually plugging in the complex number and foiling, because it would become a big mess by plugging this number in. So we take our coefficients. First of all, check descending order: 2, 1, none. And I've got 1, -5, and 1. Okay? Now, this 2 plus I is the number I'm going to put out in front. 2 plus I. Okay? And so now we work it with our synthetic division. Bring our 1 down. Okay? And then we take our 1 and times it by 2 plus I. That should give you 2 plus I. Okay? Now, we add our 2 plus I and our -5. Well, the only thing you're actually adding is the -5 and the 2, which should give you -3 plus I. Okay? So now we actually have to do one little hard part, which is take the 3 plus I and times it by 2 plus I. And that requires just a little bit of extra work, because you actually need a FOIL. So it's 2 plus I times -3 plus I. Okay? And if I work this out, I do first, and I get -6. Outers gives me positive 2i. Inners gives me -3i. And then last gives me plus I squared. And if you recall, I squared is actually just a -1. Okay? And so what that means is this is really -6 minus I minus 1, which is really -7 minus I. Okay? So this answer right here goes right up there. So I put -7 minus I. Okay? So then to finish, I need to go ahead and add the -7 and minus I to the 1, and that should give me -6 minus I. Okay, this is the last box, so this is actually your remainder. Now again, the only thing that we actually care about in the end here is the remainder. So what we're saying is that f of 2 plus I, if I was to actually have plugged that in here and here, the answer would be my remainder, this negative 6 minus I. This is your answer. Okay, so that's the part that we actually care about. So I do all the synthetic division. The only one hard part is actually foiling this part right here, and then I got my final result was negative 6 minus I. Okay? Now the last thing we have to worry about is some questions will ask you decide whether or not a number is a zero. So basically what they're saying is okay, we've got this answer, potential answer, x equals negative 5. Okay? Now this is similar to these remainder problems I just did where the number they're giving you is actually solved for. In other words, it's equal, which means you don't change your sign to do synthetic division. Okay? So we're just going to put the negative 5 in its little corner without changing the sign. Okay? Now, then you take your problem and you look for perfect descending order, and here it does, we look at 4, 3, 2, 1, none, and so this one works just fine. So now we take our coefficients, 2, 12, 6, negative 5, and 75. And the goal here is we're hoping that the remainder is 0. If the remainder is 0, so that's the bottom line, is it's a 0 if the remainder is equal to 0. Okay? So we got to check it out. So we do our synthetic division, bring down the 2, times that by negative 5, I should get negative 10. Then I combine these and I get 2, times that by negative 5, I should get negative 10. Combine this and I end up with negative 4, times that by negative 5 and I get 20. And then I take and subtract my 5 and I get 15. If I times that by negative 5, I should get negative 75. And when I add, I get a remainder of 0, which proves negative 5 is a 0. So the answer is yes. 5 is a 0. Okay? Now if there was anything else in the remainder, if there was a number here at all, then it wouldn't be a 0, and you would just say no, it's not a 0. Okay?